Okay, so this is going to be the video for the test review that we're going to be having on Friday. Just kind of going through this with you. We're going to go through this entire sheet together. So let's just move this out of the way. Okay, so the first thing is we're going to go ahead and graph these system of equations to be able to find our solution. We have to graph them, so we have to go ahead and take each one of these equations and put them in slope-intercept form. So for the first one, we have 8x plus 3y equals 12. We're going to subtract the 8x from both sides. So we have 3y equals negative 8x plus 12. When we divide the 3, we get y equals negative 8 over 3x plus 4. All right, we'll take the next one. We have 2x plus 3y equals negative 6. In this case, we're going to go ahead and subtract the 2x from both sides. So we're left with 3y equals negative 2x minus 6. Divide the 3. And so we're left with y equals negative 2 over 3x minus 2. All right, so graphing each one of these, we're going to graph the first one. Y-intercept is 4. My slope is negative 8 over 3, so we're going down 1, 2, 3, 4, 5, 6, 7, 8, and going to the right 3. 1, 2, 3. All right, and this is my line. All right, the next one, we're graphing it. Y-intercept is negative 2. My slope is down 2 over 3. And pretty easy to tell where our two lines intersect. So our solution is going to be 3, negative 4. Okay. Same thing for the next one. Go ahead and place these both into slope-intercept form first. And then graph. And find the solution. Okay. Number 3, we're asked to go ahead and draw three pictures representing 3 different ways to classify the solution of a system of equations. So we have consistent independent. Well, a consistent independent is when we have a graph with a system of equations. All right, so we have two lines that, let's say, they intersect at one point. Okay? That would be consistent because it has a solution, and independent because there's just one. Okay? The next one, we have consistent dependent, and what that simply is that we have a system, we have one line, and then we really just have the same line on top of the other one. That is consistent because it has a solution, but it's dependent because there's infinitely many solutions. And the last one, inconsistent, and consistent means that there's no solutions, so I have a set of linear equations in which my lines never intersect. So this is an inconsistent system. All right. Number 4, all we're asked to do is just verify that that particular point is going to be a solution to the system. So we'll go ahead and do the first one. We have a system of equations. We have the first equation, which is going to be 9x plus 4y equals negative 30. And then the second equation, we have negative 3x minus 8y equals negative 30. So all we're doing is we're taking the solution, which is negative 6, and plugging it in. So we have 9 times negative 6 plus 4 times 6 should equal negative 30. So we have negative 54 plus 24, and that in fact does equal negative 30. So it works for the first one. Check it for the second. We're going to have negative 3 times negative 6 for x minus 8 times 6 for y should equal negative 30 as well. We have negative 18 minus 48. Does that work? Let's see. Minus 4y. Oh, it's positive 18, sorry. So positive 18 minus 48 does in fact equal negative 30. So that shows that true, it is a solution. Okay? So solving by elimination and classifying the solution. Solving by elimination, in this particular instance, we can see that our x has a negative 9 and our other x has a positive 9. So if I just add these two together, they're going to cancel the x's out. And I have 2y plus y, which is 3y. And negative 8 plus 23 is going to be 15. So y equals 5. Now I'm going to take that y value right here and I'm going to plug it back into one of the other equations. It doesn't matter which one. I'm going to pick the bottom because there's nothing in front of y there. So I have 9x plus what y is equal to, which is going to be 5, equals 23. So I subtract the 5 from both sides, and 9x equals 18, therefore x equals 2. So my solution to this is going to be 2, 5. Okay. Number 7, I see here that I don't have opposite signs for x, but if I was to go ahead and multiply this bottom equation by a negative, then I would go ahead and just simply carry over the first one. We have negative 3x minus y equals negative 26. And then we have the second equation that we're going to multiply everything by a negative. So a negative times negative 3x is 3x. Negative times negative 5 is positive 5y. And negative times negative 22 is positive 22. Now we add them together, we can eliminate the x's. Negative y plus 5y is 4y equals negative 4, so y equals negative 1. Now again, take that y value and plug it back in to one of the other equations. We'll take the first one, we have negative 3x minus what y is equal to, which is going to be negative 1, and that equals negative 26. So we have negative 3x plus 1 equals negative 26. When I subtract the 1, we get negative 3x equals negative 27. So x equals 9. So my solution is going to be 9, negative 1. All right. We'll do one more where we have to multiply one of the equations by a number to get them to cancel out. If I was to multiply the bottom here by negative 2, I would get a positive 18 and I can get my y's to cancel. So let's multiply the bottom by negative 2. We'll carry the top equation over, which is 3x minus 18y equals 27. And then we have the bottom equation, multiply everything by negative 2. So negative 2 times 2x is negative 4x. Negative 2 times negative 9y is positive 18y. and negative 2 times 18 is negative 36. So my y's, now they cancel, and I have 3 minus 4, which is negative x, and we have 27 minus 36 is negative 9, so x equals 9. Now I can take that x and I'll plug it back into either one of the equations, doesn't matter again. Let's plug it back into the first one. So we have 3 times what x is equal to, which is going to be 9, minus 18y equals 27. So we have 27 minus 18y equals 27. When we subtract this 27 from both sides, we have negative 18y equals 0. When we divide both sides by negative 18, y equals 0. So my solution now is the ordered pair 9, 0. So what you're left to find out for number 9 is what do I need to multiply this bottom by to be able to eliminate my y values and solve from there. Okay, number 10, solving by substitution. This is again fairly easy. The first step is to go ahead and solve one of the equations for one of the variables to go ahead and substitute into the other. And I'll carry this in just a second.